All right, so a great start to the conference so far. We're going to keep that rolling. We have Tanya Jenkins, who's going to tell us about automating the Telepresence robot.
Great. Thank you. Hi, everyone. Oh, good. Wow. um, I don't, the thing is, I don't have, let's see, this. Bear with me. Yes. Great. Thank you. Good morning. How's everybody doing? All right. Good. Let me ask you something. Have you ever had a project, an automation project, that was so challenging that by the time you got to the end of it, you were so happy and it was so satisfying and it really made a difference in your career? Well, I'm Tanya Jenkins, and for the next 30 minutes, I'm going to tell you about that, how that project affected me. This is great. Automated telepresence robotic driving. So, what does it mean to be present in the 21st century? The idea of presence involves hearing, seeing, and interacting with your environment. Technology has allowed us to redefine what it means to actually be present. Before, you had to be face to face with someone. Now, you can be in different rooms, and technology took us to a place where we're in different rooms and we could hear each other, but we couldn't see each other. Then, teleconferencing came along. And what could we do? We could see each other and we could hear each other, but we still couldn't interact with each other. And what did that mean? We couldn't say, you know, who's in the room? We couldn't say, I want to go outside. We just had to deal with proxy. Someone else would have to do everything that we needed. So I think we can all agree that everyone in this room is present with respect to me, right? But what about the people that are streaming live on YouTube? Are they present? Well, they can see us, they can hear us, but they can't interact in a meaningful way. And that really makes a difference. So, what do you think? Are they present? Well, what about that guy? Is he really present? I mean, he can see, maybe if it's on the back of his eyelids. He can hear. You know how it is when you're asleep. But he's affecting his environment in some way. We agree he's physically there. So you can think about that. Is he present? Well, what about this guy? Is he present? Hi, Brad.
Hi, Tanya.
How you doing?
Good. Everyone hear me okay?
Everybody in the back here, Brad? So this is a beam telepresence system. And this is what I test. So Brad's here, he's present. He can see you, you can see him, he can hear us. We can hear him. Is he present? Well, if I walk over here, can Brad follow me? Oh. What about if I go this way? So this is the difference between conferencing, teleconferencing, and being there. Brad's present. Thank you. Do I need this for him? Oh, I'm not loud enough?
No, we're switching to handheld.
Oh, we're switching. Okay, thank you. It's like you always have to be ready for these things. So, Brad could be anywhere. Where are you today?
Oh, I'm in Palo Alto.
So Brad's in Palo Alto. Brad's in Palo Alto. So Brad could be anywhere. He could be in London. He could be in New York. He can be in Tokyo. He could be in Paris. And it doesn't matter because he's here with us today. Do you feel like you're here?
Yeah, nice conference.
Since telepresence is action at a distance, Brad can be anywhere, as I said. But what makes him present is that he can interact in the environment, and that has to do with the driving. So that's why driving is important in telepresence.
I'm going to go hang out off on the side.
Okay, great. Thanks, Brad. So I'm just going to show you a quick video. And this is, and bear with me, does that make it play? I'm not really sure how to make it play from here, but I can talk through it. Basically, this video is to show us, I just lost. Okay, great, thank you. That's not the video. Seems like Sam wants to be here too. Sorry, that's the video. And it's a quick marketing video, and I'm not trying to market it, believe me, I think it markets itself when it's here. But what I really want to show you is that the beam can be in any environment, from anywhere from corporate America to manufacturing to arts. And here we go, great, thank you. To the arts, so we have docents in museums, etc. It can even be in medical situations. And one of the things that's important is to understand that each of those people, we call these pilots, each of those pilots has their own experience that they need. They need to be on a system that's reactive and easy to navigate. They want to feel like they're walking if they're going somewhere. They want to feel like they can move seamlessly and they don't have to worry about driving the beam. I'm driving the beam, I'm driving the beam. They want to just say, oh, there's Jim, I want to go see him. Oh, Karen, wait up for me. And that's what this is. The amazing thing is that these are all different environments, and yet the beam can move around in all of them. So what was my challenge in this? My challenge was to understand that each of those people, each of those pilots, whether it's a CEO or a doctor or a nurse or a docent in a museum, all of those people wanted to feel that ease and that simplicity. So I had to focus on something, and that was the driving. So, great. Let's see if I can, okay, great. Oh, we'll get that back. Thank you. Well, anyway, while we're doing that, so you can be anywhere, and this is important. The doctor has a specialized relationship with the team that the doctor is dealing with. The CEO wants to see the different people that they're talking to, and the manufacturer wants to see what's on the floor. So, now that we know a person can be present anywhere, how do you test that? As I said, I kind of narrowed it down to the driving and that experience. And how do you automate something like that? Well, you have to figure out what the differences are in testing telepresence. One of the things that really struck me when I started using this system was that the validation of the system goes beyond the UI. It goes from looking at what the beam is doing at any given point, tracking the position and orientation of it, and understanding how that affects the pilot. I had to look at the challenges of manual versus automation. In the previous presentation, we talked about percentages of coverage. Well, I couldn't even look at it from that perspective. It was, how do you get that thing done? Automation, test control challenges, how do you get the thing to work? How do you get the thing to move by itself? And also, do I need a dedicated test environment? I think so. So, start with this challenge. Telepresence testing is more than UI testing. When you're a pilot, and you can see the picture on the right, when you're a pilot, this is what you see. You see what's in front of you about 105 degrees, and you see what's below you. And that's really good because that's kind of like walking, right? You walk, you skim ahead just to make sure you don't trip over something or run into something. But how do you translate that to automation? I mean, we have sophisticated systems now where you can, you can have object recognition, but that's kind of not what we're talking about here, because all of those environments that I spoke about, the hospital, the museum, and you really don't want to run into something in a museum with this. It weighs about 100 pounds. you have to figure out how to map that to, well, what am I seeing at any given point? Where am I? And what orientation am I in? So this is just a quick overview of the Beam telepresence system. You have, as I mentioned, a pilot, which is what Brad is, and he's using a pilot application. We call it our client application. And basically, he is directly connected to his Beam. But sometimes that requires that if a lot of people are using Beams or a network, we run over to a relay. And that in and of itself introduces some issues like latency that we'd have to deal with in testing. So, what about the challenges of manual versus automated, as I mentioned? We had, when I first went to Suitable Technologies, which does the Beam, there was one tester and he was manual. So you can imagine, you know how a startup is. You get there and it's like, great, I'm gonna automate. And they're like, well, there's some manual tests we have to do. So, you know, if you're like me, immediately you're like, how can I automate? How can I automate? They had 2 desktop platforms, the Windows and Mac. They also had just one Beam device, that one, and one driving input device. So you could use your keyboard, your arrow keys, and that's it. And you would drive around with that. But of course, as we evolved, we became bigger and had more desktop platforms, including mobile, Linux, Chrome. We had 3 Beam devices. This one actually has LiDAR because there's so many people around, which I'll talk about later, but it's object avoidance. We also had one that did not have that, and we have a little one that is really for home use, consumer product. So you can imagine, start multiplying that by the number of times you actually rev the app or rev the Beam software or rev the relays or rev anything in the infrastructure. That grew from 100 tests in one guy to one guy needing to run 1,000 tests. He was not happy. And so I started thinking really deeply about how we could automate the parts that he could do. You know, everybody here, you can automate a UI. That's really easy in the sense of, you know, getting it to click things, et cetera. But what you really, really, really need is with Beam testing is that it's not that simple. It's not just that UI. It is everything behind it, all of it coming together and making sure that the Beam is where it's supposed to be. So, you know, he looked at me and he's like, help. And so I said, I'll see what I can do to help you automate these tests. So the test control challenges, I'll just run through these. What do you use for that? How do you handle the different controls? Now we have keyboard, we have a mouse, we have gamepad, and each of those has different permutations within itself. How do you connect that all up and get it to systematically run? He was happy if I could just hook them all up to different things and just run around and have the buttons click. He would have been happy with that. How do you track the Beam's movement? How do you know where it is? You're not in the same place where a Beam is. Brad's in Palo Alto. How does he know where the Beam is aside from seeing? But again, automation, you don't have a pilot. And how do you retrieve whatever information it is that you use to track that device? Well, again, if you all are like me, you look really big first. I'm that person. I like to think about, oh gosh, what could I use? What's the greatest thing I can use? So at the time when I was contemplating all of this, I actually was taking a robotics course. And we were on the section about drones. My mind blew up. I thought, oh, drones. And we were talking about SLAM and using beacons, et cetera. And I was like, great, I just really, really, really need to figure out how I can do that and have beacons in the room and cameras and drones and slow down. But the beacons was a really good idea because the Beam has 2 cameras. It has a forward-facing camera and a down-facing camera. And if you know anything about how you use beacons with drones, you can have a beacon, which is just basically like a QR code. Let's just make it that simple. A QR code that if you hover over it, it can give you whatever information you want. So I thought downward-facing camera, put beacons all over the floor of a lab. that would be awesome. And then the beam could drive and it could know where it is at any given point if I just take a snap of that QR code. But then I realized, wow, laying out all of that stuff on the floor and mounting cameras and, the floor becomes fragile. You can't walk on it. It's only for the beam. And what happens when it rips up? And yeah, but it was really fun to think about. So option 2, I said, let me go simple because probably the solution is somewhere in between those two places. So I thought, how about just simply text on a wall? I could use OCR and, again, use the forward-facing camera, drive some known amount of distance, and see what I see. If I see, put left on one wall, right on another wall, straight, all those words. If I see the right word, yay, I know I'm in the right direction. I know my orientation is right. But we're talking about position and orientation, not just orientation and not just position. So that wasn't good enough because, yeah, I just know where I'm facing, but I wouldn't know how close I am to my target. So what was the last thing? So what would give me something that's right, position and orientation? Well, as you can see on the front of that beam, and as I mentioned, LiDAR. So that was my thought. And that was actually the biggest challenge, to figure out what exactly it is to track the beam's position. So in a nutshell, let me answer the test control challenges that I talked about. I use Frog Logic Squish. Our application is based in Qt, so I use Squish, which has a Qt layer and hooks right in. I use Python because Python is great. There's so many modules available with it. Also, it's just really flexible. How do I track the beam's movement? How to handle the driving controls? Well, I actually abstracted it. I took every device and made a library for it. It became an object, and I could pass that into the test script. Really easily pass it in, and the test didn't care what it was running, and I knew, and I passed information out, and all of a sudden, that was so much simpler. I also wrote an API for driving and abstracted the driving controls based on the objects. So it made it very simple. How did I track the beam's movement and positions? As I mentioned, it was a LiDAR. So I had to install the LiDAR in the lab and then just figure out how to take readings. But I made a course, and at each part of the course, I would then take measurements, or actually the script. When I say I'm kind of connected to my script now. It's like my baby. I think you guys understand that. The script would take start up the LiDAR and take the measurements, and that would be it at every spot in the automated driving course. So how am I going to retrieve this information once I had it? Well, the script would remote log into a NUC that I had in the lab, start up the LiDAR, and start taking the measurements, retrieving that info. Also, I should mention, the beam knows where it is at any given point, not because of GPS, but it tracks its rotations of the wheels, and it has a motor board, and we can get information from that. So I use that as a second point of confirmation. So I have the lab, the measurements I know, my expected values. It has the values that it wanted, and the cool thing, or that it expected, the cool thing from that is that now I was validating yet another part of the beam. I wasn't even thinking about that, but it really came out to be a good thing in the end of this. Okay, so what is LiDAR? LiDAR, and I have it with the different spellings because there are so many different permutations of it, but it's a surveying method that measures distance using laser light. And it's great. It illuminates the target. So basically it uses reflection and speed of light. It shoots a laser, hits an object, gets the information back about how far that beam of light traveled. So I did an animation to kind of jazz things up to show you actually how the LiDAR works. So this is a sample scan. This is not actually from my lab, but this kind of gives you a visualization. The dark portions, the bright pink, that shows intensity. So that means that there's something there and the LiDAR's in the center of the cross. And where you see the pink, that is actually things where the light can go through. So something that might be opaque or translucent, I'm sorry. And then the green is actually the vectors for each shot of the laser, and it's scanning the whole time that it's running. So it's spinning and sending out the laser pulses. So at the end of those green spots, you may see the dark red. That's actually where the light was reflected, the laser light reflected back, and that's where you get the measurements. So you set up your lab so that any particular vector, it covers what you want, the distance, the measurement that you want the distance for. So here is the dedicated test automation equipment that I had. Have the beam, of course, and a dock because you have to keep it charged, the Hokuyo lidar, and a NUC small form factor computer. Now, one of the things I experienced when I was trying this out, I was really excited, and I put the beam in the room and the lidar, and I couldn't tell the orientation. And I realized it was because the beam is symmetric, and we're looking at the base, not the top. The base is symmetric, so I had to modify the base. But of course, you don't want to make the base heavier. You don't want to change the test very much. You don't want to change the test equipment because that would skew your results. So I'm at a robotics company and I have lots of things available. I had the LiDAR, that was, part of what we had in our equipment room. We have all this great stuff. So I'm like, what can I modify this with? I took a cup and I taped it with painter's tape, and it actually worked. It made it asymmetric. So I thought that was a fun thing. It's like, party cup on the beam. So here's a shot of the lab. It's non-traditional because usually when you have a lab, it's a software lab or it's a hardware lab. But this is actually a lab for the beams. So the only computer in there is the NUC, which I mentioned earlier. And that's the actual room with the beams. So there were safety concerns. I had to have an isolated room. As I mentioned, the beam weighs about 100 pounds. So you really don't want that to be running around without a pilot who can say, oh, stop, there's someone in the way, because we would be running over everyone that walked by. You just don't want to take out the employees until the product's out at least. So the room considerations, as I mentioned, isolation. But this is not just, this is my lab, but this is not just for this testing. I have to beam in, that's what we call it. I have to beam into a lab, into the beam about 30 times in a couple of tests that I have. I have loop tests and all of this. And you could imagine sitting next to it. The first time you hear it, you're like, oh, great. Then you become trained to the fact that someone's coming on. And so you start looking at a beam when you hear the telltale noise. And then people start getting annoyed with you. Can you take that somewhere else? Brad, do you hear if you could hear the sound, that's Brad. He's coming back in now. And it's very audible. So we wanted to make sure that that was isolated and that no one had, any problems with that. And it's also interference from the outside, because when I'm doing audio tests or something like that, I want to make sure that those tests are, the value of those tests are proper. Lighting, natural and man-made light, man-made fluorescent above. And as you can see from the back of the picture, that was the light from outside. The cool thing is that this LiDAR actually affects LiDAR. So there's some great tests that we can do at certain parts of the day. So that's it. Oh, the flooring, have to mention that. So that's just common corporate flooring. This, it's important, believe it or not, because you're talking about rolling over a surface. And if it's not the right kind of surface, you actually, if the density is different than average, you will not get the right measurements. So here's another animation, and believe me, once you see the actual driving course, you'll understand why I did an animation of it for you. The beam starts at the dock. It drives to position B. I take a measurement, or the script takes a measurement there. It turns towards C, take a measurement there. It turns back to the center, then turns the other way, take a measurement there, drives back, backs up, take measurements at all those points, and then it self-parks. And that's yet another feature. It's a really cool thing. It'll align itself onto the dock so that it's always charging. So just wanted to make sure you kind of saw that. So when you see the actual thing, this is a little more exciting, but it's cool. So data collection. It's important for tracking, when I'm tracking the position and orientation of the beam, it's important to have the right type of data collection. So what did I have to collect? Well, as I mentioned earlier, it would be the position and orientation information about the beam at any given point. So in the previous slide I showed you at the different points I mentioned where I take those measurements. It's important that you do the same ones. I mean, we all do test automation, so I don't really have to explain that in that sense. But it's important, especially from the distance perspective, that you go to the same point every time and you let the LiDAR scan at that point. So I took measurements and I have an expected distance traveled, and that information is correlated with the beam's information, which is reported back through a special client that we have, and also the motorboard information, my expected values, and also the LiDAR. All of those are compared, and I have a margin of error, and if it's within the margin of error, it passes. So here is actually the automated driving course. On the left, you'll see that is the view from the test beam. The beam goes into the room and does its thing, and I had to have, a fake pilot, so I brought on my evil minion to lord over the test course. Could someone play the video on the right for me? Or if I can play it up here, I didn't want to touch anything. Great, thank you. So this is actually the video, a video of the actual course in my lab when the test is running. The interesting thing about this, what did I gain from this? I went into this, whole hog. I wanted to make sure that I could figure out everything and understand what the challenges were. I thought I had everything worked out. We often do. But I was, again, expecting something to go wrong because, yeah, that's how life is and things go wrong. I learned that I love doing this. This is great. I love the fact that I could find something that would give me the information I want, and I could cobble together a system that would effectively test. What I wasn't expecting was that there were really small things that normally a human pilot would see, and they would just say, I'll move on. But on an automated test, when you're saying, hey, go forward for 4 seconds, which given the speed of the system, it should be 6 feet. If there's a glitch, like latency, which happened, you actually don't get the measurements you want. And when you come in the next day and the tests have run, and all of a sudden, everything's red, everything failed. Oh, so I needed to add something for that. And I had put in all types of things. I thought about it beforehand. Well, if it isn't off the dock, then that's fine. I'll start the course again. The latency is what got me. And so I had to take that into account. What I did is I run the test several times, and I grab network information, and I do an average. I check the average. I check how many times it failed. If the network's down, I know what the problem is. If the network was fine, then there's something else that's going wrong. The other thing was, when the beam is docked, sometimes, even when you do auto parking, it will be charging, but it won't be exactly straight. And of course, we know if you're not, what the straight line will give you the distance you expect. But if it's slightly skewed, believe it or not, it fell outside the margin of error. So I had to adjust the margin of error for that. It was really great even solving those problems because that's something I like to do. So with that, I hope you enjoyed it. I want to thank you all for listening and dealing with am I talking into the clicker or the microphone at any given point? A big thanks to Brad for taking out some time to come and work with me here. And you want to say bye to everybody?
Yeah, thanks a lot. Have a fun day.
Thanks. And I know we're going into Q&A. I have one that people might be asking. The first one is, hey, there are beams at Google. Can I get access to them? If you're a Google employee, you can. And you can do Go Access Beams or Beams Access. And you can jump on one of the many beams that are on the campus. So thank you, everyone. I'm ready for questions.
Yeah, very good. We actually have one in the Boulder office.
Cool.
It's fun to play with.
That's great.
But yes, I have to say, Tanya, I have tested a lot of products in my career. This one looks like the funnest one that I can imagine. So many pranks I could pull in the name of testing. That would be my dream job. But yeah, after this, we're going to have a 30-minute break if anyone needs to get started on a break early, but we ran a little late on Tanya's presentation, so I want to give some time for questions as well. So we'll be doing a few questions here, and then we'll go immediately into a break. Oh, no, not your fault at all. It's Diego's fault. Oh.
We need to switch this from Keynote to the presentation. See the Keynote.
Oh, is this the wrong? Oh, sorry.
Just refresh the page.
Refresh. Thank you. Is that the right one?
Keynote.
Oh. Here?
Yes. Great.
Perfect. Thanks, Diego. All right. First question is actually a feature request to not have the Telepresence run over people.
So, actually, no, the beam didn't run over people. I was saying that's what I wanted to avoid. So I mentioned that we have 3 versions. There's one version that is the one that I use for this test because I don't want to avoid objects. It's a closed lab, and I don't want, if I get close to the wall, that's fine because that's a data point, right? If it's against the wall and it should have been in the middle, I want to know about that. Brad actually is on a beam that has LiDAR, and that has accident avoidance or object avoidance. It will actually slow down and not hit something. And so basically most of the corporations that buy them have LiDAR on them because they have a lot of people running around and they don't want anyone to get hurt. But the point is, there's a pilot on there, and if you get run over by a beam with a pilot, they want it to hit you. So that is absolutely part of the options that you have on the beam. But again, the person's driving, so they can see you, and they can see you basically with the same clarity that most of us can see anyone else.
Great. How about testing other surfaces, inclines, non-smooth, etc.?
We have a whole other place for that. One of the cool stories that came out, I didn't see this, but this was really cool. Someone was driving a beam, not with LiDAR, and we have basically it's our, I guess, production floor. So it's like a warehouse, right? And we're upstairs in engineering in just, like an office. And a person drove out the door and the beam went down the steps. And and then the person's on their side saying, can someone stand me up? I'm all right. They stood him up and he drove away. So that thing is really, really durable. But we do, that's one surface, we don't test that often. But we do, we have wedges, we have all types of things that we test with. But I think one of the main things that we do is we crowdsource our testing within the company. Everybody, half of our employees, or probably more than half, are remote to us. So they're beaming in from other countries. They're beaming in from, across this country. And they come to meetings on the beam. I've been in a meeting where there was one person, and our CEO likes to call it a meat body. Okay, there was one meat body and 12 beams. And we had our meeting. And I think that's an important thing because everybody's in a different place, and we beam out and test different surfaces in the real world. We check in with our customers, et cetera.
Any questions in the room? I think we'll take one more. So.
Hey, Very interesting. And you showed a picture where there was 2D image. So basically, does it look like 3D? Like, does it look into the height? So for instance, it looks at the surface, but if something is like
so-
above the surface?
Yes, so the LiDAR, you're talking about the LiDAR. So the LiDAR actually, you place it at the level at which you want to take those measurements. So I have mine lifted about this much off the floor because that will just correspond with hitting the front of the beam. So no, it doesn't do, at least this one, doesn't do 3D because it just sends out one laser, vector at a time at the level it's at. And it rotates on the same on that same plane, if you know what I'm saying. So the light comes this way, and the LiDAR is rotating, shooting the beams this way. So it's not a 3D surface on that plane, but everything it hits, it illuminates in that direction. Does that make sense? Okay, what do you need from me?
So if there is a hole in the floor, so basically will it throw to the floor through the hole?
No. So you're saying about where I mounted the LiDAR?
Yeah.
So, Brad, can you come over here? I'm sorry, the rest of you probably can't see this. So, this little knob on the front, this is where the LiDAR is actually mounted. So, the obstacle avoidance that the beam does is actually right, it shoots out from here and spins. So, anything at that level, it can see and avoid. So he's looking down. He can see around himself. And so it's really forward, and it's in front of you. And if you mount the LiDAR sideways, it'll scan this way. It really is just oriented the way you want to put the LiDAR.
Thanks.
That help?
That answers the question.
Okay,
Thank you.
good. I'm glad.
Good. And maybe we'll do one more. How much does all this cost, if you can give us a quick answer?
Do you include my time in this? I mean, so this particular version of the beam is about $24,000. $20,000, and then the LiDAR is $4,000. But there's a solution. There is a beam that we sell on Amazon that's smaller, and it's $2,000. I think it's $2,500. And that is shorter. It has a smaller screen. It weighs less, 40 pounds, and that usually is for home use, just not as a plug, but just kind of as an FYI. People use it to visit their family. Their family's in another place. They put a beam in a room. Oftentimes it's in the kitchen, which is really interesting, so they can eat dinner together. I don't know about you guys, but when my mom would cook, I'd want that food, so I don't want to see you eating it. I can't have it. So that's the kind of thing that people would use that for. And we found that actually a lot of people use that in the small business. And so when they have, they're not big like Google or Microsoft or places like that, they buy the smaller one. But the other, and I said the one other version is $20,000 without the LiDAR. But there's leases available. Okay, now I'm a salesperson. There are leases available, so you can get it for less than that.
All right, fantastic. Yeah. So
Thank you, everyone. Enjoy.
let's give Tanya a hand, and Brad. And we'll take a short break and start back up again at noon.